Okay, so how do we graph monomial functions or even know if they are a monomial? So here I have f of x equals 3x to the third power. Now remember, anything that can be written in the form of k times x to the n power some power is a power function, right? In order to make it a monomial, there can be only one x term. Now we could have some number added to it, right? We could have it, for example, plus 2. It would still be a monomial because we only have this one term with the x in it. If, let's say, it was plus 2x, then it would no longer be a monomial, right? So as long as it has one x term in it. Now, we know that this function is going to look somewhat like a cube function, right? We do also know that the constant of variation is this 3 number in front, right? That is your constant. And then the power of this function is to the third power. So those are two other things that I also can tell about this function. Now, how would I graph it? Well, since it's a monomial, it'd be easy to just make a table and graph it, right? We could make a table and we can say, okay, what are our x value? What is our y value, or f of x? And we can do it for 5 points at least to give us a more precise function. Now, you want to have some on the negative side and you want to have some on the positive side. So I'm going to choose small numbers, -2, -1. You want to know what it looks around the origin, so 0, and then +1 and +2, right? So now that I know what my x's are, now I can just plug them in, right? So f of -2 is going to be equal to 3 times -2 to the third power, right? Which is going to equal 3 times -8, which is equal to -24, right? So -24. Then we do the same thing for -1. So f of -1 is going to be equal to 3 times -1 cubed, which is equal to 3 times -1, right, which is just -3. So if I plug 0 in, it would be 0, right, because 0 to the third power is still 0, and 0 times 3 would still be 0. So now we can do f of +1. So 3 and 1 to the third power. So it would just be 3 times +1, which is +3. And then we do f of +2. So 3 times 2 to the power of 3, which is equal to 3 times 8, which is +24. So you can see that it is symmetrical around the origin, right? We know that it is an odd function. Now I know it's an odd function because if I were to plug in -x into my x, that would change the sign of this function, right? And if it changes the sign of the full function, that means it is an odd function, right? So it would become -3x. So that's how I know that it is an odd function. So now let's graph our points real quick. At -1, we have -3. Oops. It should be over a little bit. At -2, it's -24, so it'd be like way off the charts, right? Further than I actually have. So let's say it's approximately somewhere out over here, right? At 0, it is 0. At +1, it goes to +3. And then at +2, it went all the way up to, again, 24, right? So let's just say it's all the way up there. So connect the dots. Gives me something like this, right? Sorry, it's like way out. But it would look something like that. Kind of like the Q function, but a lot narrower, right? So with monomials, it is pretty easy just to do a table and to find your points, and it'd be the exact points for it as well.